Alrighty, so let's look at those examples I had you guys try the other day. So example 3 on the second page, so example 2, number 3. We had some cube roots, and since they're both cube roots, we can smash them up. Now, I wouldn't actually multiply the 108 and 4. I would just think about 4 really being 2 times 2, and then 108, holy moly. Okay, so 2 will go into it. Let's birthday cake this guy. He's kind of big, so 108. And then we got 54. And 2 will go into that 27 times. 3 will go into that 9 times. 3, 3, 3. Birthday candle. So we get 108, which is 2 times 2. And then 3, 3, 3. And all those are under a cube root, so we're looking for groups of 3. So I got a group of 3, a group of 3, and then 2 left over, which is a bummer. But the 3 will come out, the 2 will come out, so I'll have 6, cube root 4. Okay. On number 5, I felt like I peeked up there. Both cube roots, so I can multiply them up. So underneath, I'm going to change that 4 to 2 times 2. I'm going to change the 12 to 3 times 2 times 2. And then I have x to the 3rd. And I'll actually have y to the 7th, because there's 5 here, 2 there. And so then, because we're taking a cube root, I'm looking for groups of 3. And even though I put these in a wackadoodle order, I can still get 3 2's. So a 2 will come out. But the 3 and the extra 2 will have to stay in. So under my cube root, I'm going to have a 6. Then I'm thinking about dividing that 3 into these exponents, and 3 will go into 3 once, so 1x will come out. 3 will go into 7 evenly twice, with 1 left over, so 1y will have to stay in. So that's what you should have got there. Okay, then we also had some division ones to try. Okay, so this is a big old cube root. There's not really anything to simplify inside, so I'm just going to start cube rooting right now, which, since they're all exponents, or like variables, I'm just going to divide. So 3 goes into 3 once, so 1x will come out, no roots left. On the bottom, 3 will go into 4 once, but you're going to have 1 y left. And so, I actually didn't do one like this in the last video, but that's okay, we can talk about it now. Because the problem is you have to rationalize, you can't have a root in the bottom like that. But I can't multiply by a square root, because you have to multiply it by the same root. So I have to multiply by a cube root. And I can choose to put under there whatever I want. Just whatever I put on the top, I also have to put on the bottom, because then it's 1. I need to pick something that when I multiply it to y, I'll be able to fully cube root, because I can't have a root in the bottom anymore. And if I just multiply by y, y times y is y squared, and it won't fully cube root. But if I multiply by 2 y's, then I'll have y to the 3rd, is y times y, and that'll fully cube root, and that'll work. So because I put y times y on bottom, I have to put y times y on top. And so what happens is my numerator is just x cube root y times y, which is really just y squared, over, now on the bottom, I have y times the cube root of y times y times y, which is y to the 3rd. But then the cube root of y to the 3rd is y, smashed up against another y, which is y squared. So kind of tricky when there's a cube root in the bottom like that. Oh my word, even worse when it's a 5th root. What is this? Oh my gosh, what did I do to you? So we got negative 3 over the 5th root of x to the 6th. Now there's nothing to do on the top, there's no root around it. On the bottom we're taking the 5th root, which is really just like dividing 5 into 6. So 1 will come out, but 1 is left. And so I need to rationalize. And I have to multiply by the same root. So I have to multiply by a 5th root. And I have to multiply in such a way that when I multiply the bottom, I'm able to fully fifth root. So that means, because it's like dividing by 5, I really need a multiple of 5. And I have one x down there so far. So take a second to think about how many more x's you need to fully fifth root it. And if you're thinking x to the 4th, you would be right. Even x to the 9th would be fine, because that would be a total of 10, which is also divisible by 5. So whatever I choose to put on the bottom, I have to put on the top. Numerator is just going to smash up because there's nothing to simplify up there. On the bottom, though, we're going to have x on the outside from that x. And then the fifth root of x times the fifth root of x to the 4th is really going to be the fifth root of x to the 5th, which is just x, so x squared. Alrighty, this rationalizing stuff is nobody's fave. So, number 6 is interesting. That is a cube root, and none of the others are. So he's just kind of chilling. You're not going to be able to do anything with him. But the square roots you can do stuff with. So like the square root of x to the 5th, we can take 2 out, and I'm just going to put it up front because it looks better. But there's going to be 1 left in. And then on the bottom, the square root of 25 is 5. And the square root of x to the 16th, well, let's see. 2 goes into 16 8 times, so you'll have 8 come out. Now it looks a mess, but because the x squared, 5, and x to the 8th are all outside, and those x's are the same, you can actually divide there. So you'll have x to the 3rd, or I'm sorry, cube root of x, square root of x on top, and then on bottom the 5's chilling, but when you divide the 2 into the 8 down here, like you have 2 x's on top, 8 x's on bottom, you're only going to have 6 left on bottom because they divide out. Whew. So, those were a little bit crazy examples, but you're going to have a homework assignment to try, so hopefully that goes okay. Oh, I have one more. I forgot. Over here. Now the first one is adding and subtracting, but this middle one here, if we want to find the area of a rectangle, to find the area of a rectangle, if you remember, you do base times height. And this cute little checkerboard rectangle right here has a base length of 3 root 15 and a height of 4 root 10. And when we multiply outside numbers. We have 12 on the outside. And we multiply inside numbers, but for me, I don't really like to multiply them. I like to split them up. So for the 15, I'm going to call that 3 times 5, because those are both prime. And for the 10, I'm going to call that 5 times 2. And then since I'm taking a square root, I'm looking for groups of 2. So 5 will come out and multiply up with the 12. So you'll have 60. The 3 and the 2 have to stay under, so you'll have root 6 left over. And that's probably a little bit more like what you should expect. So, good luck.